All right, so today we're going to look at functions and interpreting functions. Okay, so we'll look at function notation and looking at a graph and how to interpret, how to answer questions with greater than, less than, equal to. Okay, so the what, why, and how. We're going to learn how to use function notation with more than one linear function. Why? Mostly because you'll see this sort of notation in calculus. Okay, and then how do we know if we've accomplished today's what? When you can find when f of x is greater than 0, when f of x is this linear function. Okay, so let's take a look. All right, so notice we have our graph, we have f and we have g. So this one's labeled f, so that's this line. This one's labeled g, so that's that line. And if we're asked something simple, find f of 5, we would go to 5 on x. So 1, 2, 3, 4, 5. And then we would go to the line that's labeled f, and that's right here. So f of 5 is negative 1. So the answer is just negative 1. I know it represents the point 5 comma negative 1, but f of 5, it means what is f at 5? That's negative 1. Okay, g of 5 would be up here because that's g. That's the line g. So g of 5, just talked about that, is at 4. So g at 5 is equal to 4. Now it's asking when is f of x equal to g of x. So whenever you see the word when, and you'll see that this unit, we're talking about the x-axis. So we're going to know what x value causes f to equal g. Okay, so at what input gives them the same output? Well, that's where they intersect. Okay, it's where they intersect. So here at 2, when x equals 2, they have the same output of 1. So the only thing we care about is the x value. So that's at x equals 2. Now we want to know when is f greater than g. Okay, so that's going to be an interval. That's going to be like a big area. So it's going to be more than one x value. So we'll use, you could use less than or greater than inequalities, or you can also we'll look at interval notation, okay? So we'll sort of learn that too. So when is f greater than g? So when is my f line above the g line? So here's my f line, and here's my g line, okay? So what happens is here, f is above g. It's still above, f is still above g, f is still above g, f is still above g. It's all the way above g, and then all of a sudden they're equal, okay? And then as you move along, f is below g. So once they're equal, f goes underneath g. So what we're interested in is we're interested in all of this right here, all of this, everything over here. And we're looking at when again. So there's that word when. So now we're looking at x values. So now we're looking at the x-axis. So we're looking at all these values. So everything from 2 to the left of 2 will give us an f value that's greater than g. Okay, so we want all of this. So from 2 to the left. So that could be x is less than 2, or we use interval notation. Okay, so this is just showing you that F is above G, and then afterwards F is below G. So I'm drawing my lines from F to G. So I would draw them down, and then once they intersect, I would have to draw my lines up. Okay, I'm not saying you guys would do that. I'm just showing you. So all I care about is this part. Now, this is interval notation. You guys should have done something like this in Algebra 2. So it's always from left to right. So from negative infinity, way over here, negative infinity, all the way to 2. Okay? And we use a parenthesis when we don't include it. We use a bracket when we do include it. Now, we're not including anything. Now, we never include infinity because we'll never get there. So infinity will always have a parenthesis on it. Okay? And then 2, because we're only looking when f is greater than, not greater than or equal to, we'll use a parenthesis on 2. Now, if this had an equal to here, then the 2 would have a bracket. It's like a square. It's like a squarish parenthesis. Okay? So from negative infinity to 2. Okay? Always left to right. So like if we wanted this region, if we wanted all this, we would say 2 to infinity. Okay? So it's all of this. So here it's when is f of x greater than or equal to g of x? So again, we want, f of x less than or equal to g of x. We want f to be underneath g. And from here on, from this x value on, f, my f line, is going to be below the g line. So that is my interval from 2, starting here, from 2 all the way to infinity. And I want to include when they're equal. So I'm going to include the 2. I'm going to include it because that includes when they're equal. So I'm going to put a bracket on 2, and I'm going to go all the way to infinity. So from 2 to infinity. What is the domain of f? So like how wide is f? Does it go? Well, it stretches to the left forever, and it stretches to the right forever. Okay, so that is all real numbers. And we'll use interval notation, and we'll say, excuse me, negative infinity to infinity, because it starts from negative infinity, and it goes all the way to infinity. I mean, we'll never see that, but it would keep going on and on and on to the left, and this is going to go on and on and on to the right. Even though it's going at an angle, it's still stretching out. Domain of G, same thing, and that's for all linear functions. All linear functions will have a domain that is all real numbers. Okay? And then this. What is the range of f? So how high and how low will it go? So this is going to go up to infinity, and it goes down to infinity. But we want to, we actually want to start from bottom to top. So from way down there, it's going to go to negative infinity. It's going to keep going up, and reach infinity. So that is all real numbers. Now, the range doesn't necessarily, not all linear functions have a range of infinity, from negative infinity to infinity. Okay, because if it's a constant function, then that's just like a straight line, a horizontal line. That's not going to go up and down forever. So actually, I think I have some examples on here. Okay, so we learned, a few things. We're looking at the notation, right? Like using f and g's, and then also this interval notation. Okay, so that gives us, x values that stretch and go, covers a big space rather than just one single item, one single entity. Okay, example 2. So let's use our notation. So think about what you think the answers are, all right? So f of negative 2. So if I go to negative 2 and I go to f is down here. F is down here at negative 1, right? So my answer is -1. Okay, f is always going to be -1. F will always be -1. Look, the output of f is always -1. That's a constant function. That's a characteristic of a constant function. The output is always the same. So that means that's gonna have a weird range because the range doesn't change. The output does not change. Okay, the range of f is not going to be -infinity to infinity. It's just going to be at -1 because that's all it's ever going to be. So g of -4, so let's go to -4, 1, 2, 3, 4, and then we want to go to g. So the line g is right there. So f of -4 is 1, 2, 3. So again, we look at when, and we're looking at x values. When is f equal to g? So when, what x value causes them to be equal? Okay, well, they're equal right here. And my x value is right there, so that's 2. Okay, so x equals 2. Again, we're looking at when, so we're looking at x values. When is f greater than g? Okay, so I have my f line, I've got the g line. Here, f is underneath. It's underneath g. It's underneath g. I want it to be greater than g. Okay, they're equals to. Now f is above g. F is above g. It's above. It's above. Okay, so from this point, from this spot on, f is it will satisfy this condition. F is greater than g. So I want from here, this x value, all the way on. So all these x values will produce an f, which is just -1, that's greater than g. You know, so like here, right? F is -1, and then g is -3. Okay, that means that f is bigger than g. Okay, so we'll use, since it's not an equals to, there's no equals to, we'll use parentheses. So it's from 2 to infinity, right? From 2 all the way to infinity. That's why it's parentheses. Okay, here, when is f of x less than or equal to g of x? All right, so here's where they're equal. Remember, f was greater over here, so f is going to be less than over here. But look, it's below it. So we want all these x values here, and we want to start from the left. So what's way over here? What's as far to the left as possible? It's -infinity. So -infinity all the way to the value of 2. Okay, and we're going to include 2 because of that equal sign. You never include infinity because you'll never get there. You will always have a parenthesis on infinity. So from -infinity to 2. And we use a bracket because, of course, we include when they're equal. We include 2. Okay, so -infinity, you move along all these x values all the way to 2. Will give us an f that's underneath g. That's less than g. Okay, what's the domain of f? Well, it's going to stretch left and right forever. So all real numbers. That's -infinity to infinity. What's the domain of g? Well, again, it's a linear function. Okay, left and right forever. It'll stretch to the left. It'll stretch to the right forever. Now the range of f, that one's a little bit different because it's a constant function. So it's a horizontal line. Okay. So the only output, the only height it's going to be is at -1. That's it. So I'm just going to write it as -1. That's it. Okay. So try this one. Okay, take some time and just try it. Just like pause it, and then from there, once you're done, then play the video. Which you're correct with is cool. Which you're not, you're not. But put some time in. Don't just watch me and try it. Okay, the more you try it, the more you think, and the more you're going to learn. Okay, so f of 0. So here's 0. F is right here at 3. So f of 0 is 3. G of negative 3. So negative 3 is here, and the line G is right there. That's negative 2. Okay, and no matter what I put inside of here, these answers wouldn't change because these are constant functions. This is always negative 3, and this is always negative 2. Okay, when is f of x equal to g of x? When do they intersect? They never will. Okay, so that one is a no solution. Or you can put the 0 with a line through it, which is empty set. Okay, if your answer is 0, don't put a 0 with a line through it. Okay, because remember we talked about that. 0 is something, and then no solution or empty set is nothing. It doesn't include 0. So don't confuse the two. When is f above g? So here's my f line. Here's the g line. Okay, f is always going to be above g. Always. It's going to stay like this. It's going to stay at 3, and this is going to stay at negative 2. So from negative infinity to infinity. When is f less than g or below g? When will f be below? When will this line be below that line? Well, that'll never happen. It'll never happen. So again, we have a no solution or empty set. What is the domain of f? The domain? Well, it's going to stretch left and right forever. Domain of g, same thing. Okay? Remember, as long as it's a function and it's a linear function, domain will be all real numbers. Okay? Only time it wouldn't be is if it was a vertical line, but then once it's a vertical line, it's not a function anymore. It doesn't pass the vertical line test. Okay, we're looking at functions. What is the range of f? Well, I talked about that. It's not going to change. Okay, it's always going to be at 3. It's always going to be at 1, 2, 3. That's the height. How high, how low. It's going to stay at 3. All right, so hopefully you guys did pretty well on this. I know the actual interval notation can be confusing. I know looking at the graph and think of these inequalities as asking about the x values. That gets confusing, but we'll have more practice to get you guys a little more used to it. All right, so that's it. Let me stop it here. Not sure how to do it now. I think I can go back to here.